This is Joe at Sierra Specialty Auto. Welcome to the shop. I have a Tree 2 UVR milling machine. Old one. It was old when I got it, and I've had it 20 years. Did not have way covers. I installed not too long ago a rear way cover. It was pretty straightforward. Used a standard Bridgeport type rear cover kit. I'll show you that in a minute. I also want to put a front way cover on, but this machine is not set up like a Bridgeport or most of the clones. The table overhangs the dials by quite a bit when it's all the way out. We'll go take a look at that and see what the issue is with installing a way cover on the front. Here's the rear cover. Pretty standard. Little angle bracket up here, angle iron up here to hang it off the top of the V-way. Let it roll around over the way, and a flat strip in here to mount it to the back of the saddle. And here's the front. This is the wiper for the saddle, and here's the way on the knee. Exposed right now, but when I bring the saddle all the way out, it comes out to about here. So I can't just mount a bellows or a flat rubber cover onto this surface, because this wants to overhang. I'm a little fortunate here in that I have aftermarket power feeds installed on the Z and the Y, which bring these dials out by an inch and a half or so on each one. Actually, this one farther than that. So I can still see my dials under a way cover. Let's go take a look at the materials that I've gathered and see how I plan to use them. Here's the way cover. I have a folded bellows, 12 inches wide, and here's a really rough sketch of what I plan to do. Here's the face of the casting. This is a nut we'll tap and thread. We'll drill and tap in here for these 5/16 socket head cap screws, or 3/8 cap screws. We'll mount one of those here with a piece of brass tube stock, cut the right length on each side to hold this piece of flat aluminum stock, one of those at each end, and then I will sandwich this bellows in here with a piece of 1/2 inch wide aluminum bar stock over the top to hold it in place, and every couple of inches a number 6 socket head cap screw to hold it in place. And now these have to be pretty carefully located on the face of the saddle in order to have clearance for tightening the nut and avoiding interference with the bellows as it goes in and out with this rigid strip here that'll be traveling with the end of the bellows. So let's go look at what I got figured out for that. Here's another look at the saddle at full rearward extension. And there we can see how the machine surface comes into view. So I need to locate this threaded hole such that the lobes on the nut, the corners of the nut, clear vertically and at this angle toward the housing, and at this angle to the clearance point of the dovetail. So I measured across the flats here from here to here, across the corners at about 5/8 of an inch. So I figured 3/4 of an inch should be enough, a 1/16 on each side. Set the old caliper hermaphrodite to 3/8 of an inch, and I've marked this up with some blue magic marker and pulled the line on each from each surface, and I can see that they are well clear. That intersection puts the nut well clear of the housing, the mounting collar for the power feed. So that'll work fine. And then over here we got plenty of room to work. We don't have interference here, but we do still have to clear the top and the side of the dovetail. So that dimension ought to work fine. I've got a spot there, crosshair there to work from. I'm going to take this hand wheel off temporarily to be able to get in here and work in a straight line for center punching, drilling, and tapping at this point. I've got my center punching done. I'm going to start with I believe this is a number 25 aircraft length drill bit. Get a pilot hole and then take that out to 5/16 and then get a tap. Let's see how straight I can get these. That's about 1 inch deep. That should be enough. A wee bit more. That should be enough. Now for a 5/16 tap drill. Now for a 3/16 tap. I have two options here. I could use this tap head on a ratchet wrench, or I have this ratcheting T-handle, which I think will work just fine in here. And it's tight. Well, actually, it's very tight. I'm going to have to think about whether I want to take that head off of here to get into that. I can't get a straight shot on that. Let's try this one and see how it works. That's working quite well. Let's run this in, then I think I'll take that other power feed off of there so I can get a straight shot. I don't want that going in at that angle. We are cutting this dry, of course. This is cast iron, so no cutting oil here. And that's bottomed out. I'll take this taper tap out and follow up with a plug tap. And then I'll meet you back here after I have that after I have that power feed off, so I can get a straight line on that other side. Well, I came up with a plan B. I found an 11/32 12-point quarter drive socket that fits the square drive on this tap pretty well, and I've got that started nice and straight in there. So we'll do the tapping on this side with this combination of tools. All right, now let's put a couple of fasteners in here temporarily and get a measurement between those. We have 375, very close to it. Perhaps let's call it 3 and 700, or 37, 370. And now we need this dimension. And that is 8 and 670. That's a fortunate coincidence. So I'm looking for 8 and 300 center to center. Let's get on that and see how that looks. That looks right. 8.3 center to center on those holes. I'll do all of this drilling on the mill with the DRO, but I like to lay this kind of stuff out, put some, let's call them witness marks on here, so that I'm pretty sure when I get there exactly where I'm going to be, that I'm in about the right place. So I got lots of these number 6 screws. I'm going to put these about every inch, well, exactly every inch, for 2 reasons. Number one, that's a pattern of 11 inches, and there's not 11's a prime number, so there's no good match on the pattern if I try to do anything else. And this is pretty flexible. This is a pretty fragile piece of aluminum. Not much. It's only 1/16 inch thick. And so it can use the extra reinforcement. And then here I've laid out 8.3 inches apart and 5/16 in from the edge. The 3/8 inch fastener will be centered on that, and the back edge should be right on the 1/2 inch mark to clear the the shank of the bolt will clear this retaining strip, and then I'll have to mill in scallops in here, relief, for the head of the fastener. The fastener will be on here, and then this piece will come up against it. So I'll have to mill relief right here for this fastener. So we'll go to the milling machine and get set up for that, and see you there in a minute. I've got quite a bit of stick out here, 3 inches outside the vise jaws on this 1/4 inch thick or 1/8 inch thick material. But I think with these small holes I'm drilling, I believe I'll be able to get by going down here. And these don't have to be terribly accurate in position anyway, as long as they're close enough to look good. So I'm ready to find the end and the edge with the center finder, and then start working my way down this 1-inch pattern with a number 36 tap drill. We'll be running the edge finder and the tap drill at the same speed, at somewhere in the neighborhood of around 1800 RPM. A little bit on the high end for edge finder, but it'll work fine. We're ready to load up a drill bit and run that pattern. Gonna leave quite a bit of it sticking out on this stub length machine screw machine length drill bit to clear the clamp there. So let's come over 500 and in 250 for this pattern, 1/4 inch. There we are. Now let's see if we can drill some holes. Quite a bit of flex there. Let's set up a jack screw to hold that end up. There's a stack of blocks and shims that ought to do for this temporary job. All right, that's got the pattern in both strips. I will go off camera later and drill out these to a clearance diameter for the number 6 machine screw. I'm going to come back with this setup and power tap these holes with the 632. I'm set up now for the tap. Nice sharp new tap. Put a dab of cutting oil on every hole and should be able to just run zippity-doo right through that pattern. Let's turn this mill to a little bit slower speed that I can have a chance of keeping up with. That was a little bit sketchy at the outboard ends, but we got her done. Now I'll set up for the 3/8 inch clearance holes for the main bolts, and I'll set my set of blocks and shims up under each end while I drill those holes. I centered up on the pattern and re-zeroed so I can go 4.150 from each side of center. We're set up for the first one. Let's do that, traverse across and get the second. Spotting drill first, and then 3/8 inch through hole. All right, we need just a little bit of deburring on that, and need to set this thin strip up for the scallops for the bolt head clearance. Be back in a minute. The head of my fastener measures just under 11/16, so I have an 11/16 end mill in the collet. I've touched off on the edge at 4 1/50, half of my distance from center, and I figure I need around about 3/16 of an inch into the width of that in order to comfortably clear the head of the fastener. So I'll just bring this into 187.5 at a pretty good speed, and I've got a clamp set up on my stack of blocks and shims to try to put a little rigidity into that. Let's see how it works. I'd say that worked pretty well. Let's move the blocks to the other end. Traverse over to the second cut. That'll finish the milling operations. I need to deburr all this stuff, and then it's time to calculate the length of the standoffs, the pieces of brass tube, to hold this mounting assembly out far enough to clear the slide. I think that's a pretty good start on this project, but I'm out of time tonight, so I'm gonna knock off for the evening. I'll finish up this project tomorrow, and I'll complete the documentation in part 2 of this video. Thanks for watching.